Right. So let's start here. So my right angle triangle is triangle ABC. I have a right angle at point B, and I draw a line from point B to point D such that another right angle is formed at point D. In other words, BD is perpendicular to AC. Now, what is important to note is that two bigger circles. I can draw a circle through a line BDC, so not line, but through the points BDC, and I can draw another circle through the points A, B, and D. All right. So what is quite important to note is the following. Watch this now. Okay. So obviously, if angle BDC is a right angle, this one here is also a right angle. Now, if we use the converse of angle in a semicircle, what does that mean? It means BC is a diameter, so that means there's a center there, and it also means AB is equally a diameter. Once I have done that, I want you to watch something very interesting. I must actually mention, I think I forgot to mention that. We're gonna sort of treat AB as a tangent to the circle BC. We sort of going to treat a line AB as a tangent to the bigger circle. And if I treat AB as a tangent to the bigger circle, I want you to then be aware of the fact that this angle here, maybe call it angle X, will actually be equal to that angle there. I want you to note that. And that this angle, that angle X or angle ABD will actually be equal to angle C. Please take note of that simple concept. This is actually one of the little things that will help you to relate, like to note which angle should be equal to which angle. And I hope you do note at the stage. Remember, the Pythag theorem says all these three triangles that are formed, by the way, I hope you note that there are three triangles formed here. There's triangle ABD, there's triangle CBD, and then there's triangle ABC. Okay. What the theorem says is that all these three triangles are actually similar. And what I have found is students have often had to memorize, cram, seriously, do some serious cram, pass, forget, and cram, and be like, which angle should be equal to which angle, that kind of a thing. And for me, that doesn't sit well because then you're missing the concept. Right. Now watch this. The next method of you comparing, oh, by the way, did I say assume? I said assume, right? But we're not going to assume. So remember, I said this is now a diameter. We have a theorem that says radius is perpendicular to a tangent. So AB must be a tangent because of this 90-degree angle here. So it's actually not guesswork. Now, another one is, I'm going to say to you that this diameter of the bigger circle is actually a tangent to the smaller circle because again, we have a radius being perpendicular to a tangent. So remember, whenever they ask you to prove that something is a tangent, one of the things you can use is the converse of red 10. So that's actually what I'm doing here to show that AB is a tangent and BC is a tangent. Okay, AB is a tangent to the bigger circle, BC is a tangent to the smaller circle, respectively, by using the fact that a radius is by default is perpendicular to a tangent. So the fact that I have managed to show that there is a right angle between the two, it means they are tangents. And one is a radius. So when one is a radius, the other is a tangent. When one is a tangent, the other is a radius. I think you get what I mean by that, looking at the small and the big circle respectively. Now watch this. In the same way then, if I look at BC as a tangent, then this angle here becomes equal to this angle here by tan chord. Same reason, tan chord. So then I can bring the following results. And this is the beauty of this whole story. I can bring the following result. I can say, okay, Clearly, by the look of things here, if I start with the two small triangles that are inner here inside, I can clearly see that triangle A, B, D is actually similar to the following triangle. B, remember it is angle A which is equal to angle DBC here. B, and then after that I went to the green, I went red, green, so I must do the same thing, red, green, so C is next, and then I went to the right angle triangle, and that's the same thing that I'm going to do there. So actually these two triangles are similar. But not only that, what you also know is the fact that you can actually look at the main triangle, triangle ABC, the big triangle now. And guess what? If I look at triangle ABC, in fact, I'm going to look at it this way. Watch. I want you to see this. This is beautiful, guys. It just melts my heart. I'm going to start at the red. Triangle ABC, the big triangle, also has a red angle, which is A. But then it also has a green angle, which is angle C. Then it has a right angle, which is which is angle B. So I don't even know why I wrote it there, but surely this is also similar to both triangles, just like that. So if you don't want to memorize which angle is equal to which, because listen, they're not always going to use ABC. They can say PQR, they can say MNQ, they can say XYZ. And what do you do in that case? So I don't want you to memorize and say, or if it's like this, then it's like this. What I want you to do, I want you to have fun. Whenever you see this Pythag situation, draw your two circles, okay? And then once you have done that, establish your tangents and apply tan chord sort of relationship to actually link the pair of angles that are equal. Now, once you have done this, here's the beauty of it all. Here's the best thing about this thing, guys. Watch this. We're going to apply our similarity, and I want you to see how these ratios come to life without you having to force them. Once I have done that, I will go on to actually prove the theorem of Pythagoras for you. So let's watch what is happening right now. Right now, by just looking at the first two triangles, I can actually draw the following conclusions. I can conclude that AB over CB or BC, let's just go alphabetical order convention, it's fine. So I can say AB over BC, and by now you all know how I get these ratios. This is BD over CD, but this is also what? AD over BD. Now, you always worry, where do I get these square ratios and all that kind of thing? Watch, guess what? There you go. I want you to see it. By just looking at that, it turns out that BD squared, and I want you to see it, guys, BD squared is actually equal to AD times CD. Take note of that. That's what BD squared is in this case. All right. Is this the only square that I have? Well, clearly, yeah, that is the only square that I have. BD squared is just AD times CD. That's it. I'll leave it there. Then I'll go for another pair, okay, of similar triangles. Remember, there are sort of three ways to go about this. So that's one way. Another pair that I'm going to get, I'm going to extract from this last two. So I've taken the first two. Now I'm taking the last two. So as a result of taking the last two, I want you to see what happens. The following ratios must be true. BC over AC must actually be equal to CD over BC. We said we're going alphabetical. And this must also be equal to BD over AB. And again, we're going to go for, okay, Yeah, let's just give it a few minutes to allow others to join again. The 1 hour had lapsed. All right, let's continue, guys. Let's continue. So what we have now, I want you to notice again from the greens, there is somehow a square again that comes up, and this time it's BC. If I take those two, I'm just focusing on the squares for now. Of course, there are others that you could have looked at. But if I focus on these two, from here it turns out that BC squared, what I want you to see this again. Watch, BC squared in this case is equal to, watch this now, AC times ACD, or CD times AC, really up to you. But that's what BC squared is. And then finally, I'm going to take the last combination, and it's going to be, let's use what? Red for the, or black for this one. I'm going to take the first and the third. So we took the first two, the last two. Now let's take the first and the last. If I extract and make set up those ratios from that, listen to what comes up. We have the following now. AB over AC must be equal to BD over BC, and this must also be equal to AD over an AB. And I want you again to note, I'm going to go for ratios that are going to give me a square. It is this one here. So this one will give me the following. I will get AB squared equal to AD, let's write it down, AD times AC. That's what happens. Now, I want you to note something very interesting actually. We have an AB squared, we have a BC squared. Is that BC squared? Yes, I think I've got an AB squared, I've got a BC squared. I'm missing an AC, hey? I should be having an AC actually. Oh, well, hang on, hang on. It's not a train smash. We actually want to prove Pythag actually, so we want to show that this is actually AC squared. Yes, I remember now. So let's go for it. Watch. I want you to see. I'm innocently going to take the following. I'm innocently going to work with AB squared, and I will also take BC squared. I'm just going to take those two. Now, let us just see what happens. Apparently, AB squared is, it's an AD, watch this, times an AC. What about BC squared? That's an AC times a CD. So it looks like I can actually factorize AC. And when I factorize AC as a common factor, I want you to see how Pythag comes out nicely here. When I factorize that, I end up with an AD times a CD. No, plus. Oops, my bad. I must have a plus here. I'm factoring out AC. I'm left with an AD plus a CD. And this is your proof of Pythagoras theorem. I want you to see now what happens. Watch this. AD is this portion here. This is what AD is. CD is this portion here. That's what it is. But this entire portion is actually AC. So that means I can replace AD plus CD by AC. And obviously, I end up with an AC times AC, which is AC squared. So just like that, you have actually proven the theorem of Pythag in this situation. You have proven the fact that indeed the square of the other two sides in a right angle triangle is actually the square of the hypotenuse. That is the beauty of understanding this thing from a conceptual point of view instead of just memorizing it. You can see your squares come up, and just like that, you are able to prove the theorem of Pythagoras. All right, so this is the long and the short of it. And I really hope and trust that you have found this to be very insightful and pretty much an eye opener. What I'm gonna do right now, I'm gonna bring out a problem for you to try, or you may regard it as a homework problem, but that's what I'm gonna do at this stage. I'm just gonna arrange that, and then your job is to just go and apply the theorem of Pythagoras. Okay, so I'm not gonna uh, belabor this and make you do a whole lot of things, but all I will do is here, I will ask you to actually uh, do this, only this one proof for me. Okay, so let's just get the sketch. So here is the sketch, and I'm gonna bring the questions. And here are the questions. For a change, the last two questions in this are marked with an asterisk, which means they are slightly challenging, or they just need you to think a little bit more. So it doesn't mean you cannot do them. I promise you, you have what it takes to do them. Have a look at this. As you see this, try and see the theorem of Pythagoras. This is the formal theorem, and you know, when you use it, so in other words, you don't have to go through the process of proving that the three triangles are similar. Once you see this theorem, you can actually right away say, well, this triangle must be similar to that, and it must be similar to that. And you will just give a reason and say, line from the right angle vertex perpendicular to the hypotenuse. That's going to be your reason. So when you look at this, you don't have to go all the way out and say this is similar to, no, you just have to decide what are the three triangles that are similar in one main big triangle, and all that kind of thing. Let me not spoil it, but you should see it. Okay, so we will leave it here for today, guys. I hope, as I said, this has been insightful. If there are questions, I will stay in a bit for those questions, but otherwise, I'll stop it here. Everyone is more than welcome to exit, but those who have questions, you can stay up and ask your questions.